Now some more problems in parallel AC circuits. Here example 14.32. So in a series parallel circuit, the parallel branches A and B are in series with C. So the impedance are ZA is equal to 4 plus J3, ZB is equal to 4 minus J16 by 3, ZC is equal to 2 plus J8 ohms. So here the current IC is equal to 25 plus here IC is equal to 25 plus J0. Draw the complete phasor diagram. Determine the branch currents and voltage and the total voltage. Hence calculate the complex power, that means active and reactive power for each branch and the whole circuits. Now the impedance of branch A, that is denoted by ZA. So here ZA is equal to 4 plus J3, it is in rectangular. Now the polar form is phi angle of 36 degrees 52 minutes. Now ZB is equal to 4 minus J16 by 3, that is equal to 20 by 3 angle of minus 53 degrees 8 minutes. ZC is equal to branch of C impedance is 2 plus J8, that is equal to 8.25 angle of 76 degrees. So now here see the figure. Observe the figure. Here the applied voltage is V. The applied voltage is V, and the impedance of branch 1 is, that is 2 plus J8, that means 2 ohms and 8 ohms. 2 ohms is the resistance, 8 ohms is the inductance. And two branches, now this is the branch C and the branch A and B in parallel. That is, A branch is 4 ohms and 3 ohms. Branch B is 4 ohms and 16 by 3 ohms. The current in branch C, IC, the branch impedance is 2 ohms and 8 ohms. The current in that flowing, the current is IC, and this current is divided into two branches. In branch A, the current is IA. In branch 2 or branch B, its current is divided into branch IB. Now this voltage, so the branch C voltage across the impedance of 2 plus J8 ohms across the voltage is VC, and AB branches voltage is VAB. So this is denoted by VAB, and here the series voltage is denoted by the VC. Here IC is divided into IA plus IB, V is divided into VC plus VA, B. So now see this one, IC is nothing but it is in x-axis. It is divided into IB, IA. That means the resultant current of IB and IA which gives the IC, and V is, that is V, voltage V which gives the resultant voltage of VC and VAB. So here this it's showing the phasor diagram. It's showing the phasor diagram. So observe this one. So V is combination of VAB and VC, and IC is combination of IB and IA. So this is the phasor diagram. Now here, so IC is equal, what is that? IC is equal to here, the given IC is given, how much they given? How much they given? IC is equal 25 plus J0. 25 plus J0. That is equal to 25 angle of 0 degrees. What about VC? VC is nothing but here, this is VC. VC is nothing but what is that? IC into impedance. Which impedance? Series impedance. So VC here, observe this one in the circuits. VC is equal to IC into Z series impedance. That is, what is the impedance here? 2 plus J8. So IC into impedance, VC is equal. Now here, VC is equal to IC into ZC, that is equal to IC is 25 angle of 0 degrees, and ZC is here, what is the ZC here? See this one, 8.25 angle of 76 degrees. So substitute in this VC equation. So we'll get the 206 angle of 76 degrees. 206 angle of 76 degrees. Now ZAB is equal, what is the ZAB? ZA and ZB both are in parallel. So here ZA is 4 plus J3 and ZB is 4 minus J16 by 3. So here substitute those in ZAB equation. So 4 plus J3 into 4 minus J16 by 3 divided by 8 minus J7 by 3. That is equal to, so which result in, so 32 minus J28 by 3 divided by 8 minus J7 by 3. So now from this we get the value of ZAB, that is equal to 4 plus J0, that is equal 4 angle of 0 degrees. 4 angle of 0 degrees. So ZAB is equal to 4 angle of 0 degrees. That is the ZAB value. Now go for go for VAB. VAB is nothing but see here VAB voltage across the AB branches, these parallel branches. So here this parallel is calculated, that is impedance is ZAB. So what is the current here in these two parallel cases in two conditions? So the resultant impedance is ZAB and the current is IC. The current is IC. Here VAB is equal to IC into ZAB. That is the formula for voltage across AB branch. See here. VAB is equal to IC into ZAB. That is 25 angle of 0 degrees into 4 angle of 0 degrees. That is equal to 100 angle of 0 degrees. Z is equal to ZC plus ZAB. Here what is the total impedance? Z. That is ZC plus ZAB. Here ZC is, what is the ZC value? 2 plus J8. And what is the ZAB? 4 plus J0. So now total impedance, the resultant of the impedance of circuit is, so 2 plus J8 plus 4 plus J0, that is equal to 6 plus J8. This is the value of total impedance in rectangular. So now we'll get in polar that equal to 10 angle of 53 degrees 8 minutes. So this is the total impedance of the circuit. Now go for the voltage across the circuit. Total voltage, that means the applied voltage across the circuit, how much? So here V is equal to IC into Z. Here Z is the total impedance, IC is the current flowing in the circuit. So now IC is 25 angle of 0 degrees and Z is 10 angle of 53 degrees 8 minutes. So that is gives the V is equal to now 250 volts angle of 53 degrees 8 minutes. This is the voltage across the supply. Voltage across the total circuit supply voltage. So that is called supply voltage. Now calculate the currents in A and B branches. So now A and B branches, so current in branch A is equal to, what is that formula? Voltage across the AB branch divided by the impedance of branch A. So that is equal to IA is equal to VAB by ZA. What about VAB? VAB is 100 angle of 0 degrees. What is the ZA? ZA is, so here ZA is 5 angle of 36 degrees 52 minutes. So they did not write correctly, so make the correction here. So IA is equal to VA by ZA, that is equal to 100 angle of 0 degrees divided by 5 angle of 36 degrees 52 minutes. That is the current in branch A. So now we'll get, what is that? 20 angle of minus, that is equal to, here write the, so 520 is 100. So 5 angle is, so 36 is denominator. So this is, so convert into upward side, which gives the minus. So 20 angle of minus 36 degrees 52 minutes. Here 20 angle of minus 36 degrees 52 minutes. Write the current. IA is equal to 20 angle of minus 36 degrees 52 minutes. Now IB is equal to Now IB is equal, what is IB here? IB is equal in the branch current B. So now VAB, voltage across the AB branch, divided by the impedance in branch B. VAB is 100 angle of 0 degrees. So now ZB is, what is the ZB? 20 by 3 angle of minus 53 degrees 8 minutes. Angle of minus 53 degrees 8 minutes. So make the correction, angle of minus 53 degrees 8 minutes. That gives the, what is that? 15. So here that gives the 15 angle of 53 degrees. Here 53 degrees 8 minutes. This is the 15. IB is equal to 15 angle of 53 degrees 8 minutes. So here various voltages and currents are shown in figure. So here in 14.38b, so here for various voltages and currents are shown in figure. So here see, observe this one, the phasor diagram. So first you have to see the voltages. Here VAB and VC is calculated. The VAB and VC is nothing but it's a resultant or combination or arithmetic sum of these voltages, which gives the voltage V. Voltage V. So now go for another current. Another parameter is current. So the current parameter. So here series, the series current, that means branch C current is IC, that is given 25 angle of 0 degrees. 25 angle of 0 degrees. So that would be taken in x-axis, that is the reference. So here it is the reference IC, and IB is, what is the IB here? How much IB? See here, IB is, so VAB by ZB, that is the formula. So value is 15 angle of 53 degrees 8 minutes. So 15 angle of 53 degrees here. So the phase angle between the VAB and IB, or otherwise IC and IB. So here the phase angle between VAB and IB is 53 degrees 8 minutes. This is the phase angle between the VAB and IB, or otherwise IC and IB. So now next one is, so IA is equal 20 angle of minus 36 degrees 52 minutes. Here minus 36 degrees 52 minutes. Here this is minus 36. It means it drawn in the fourth quadrant. Plus 53 8 degrees means it drawn in the first quadrant. IB is in first quadrant, IC in fourth quadrant. So this is minus 36. So IA is minus 36 degrees. IB is 53 plus 53 degrees. So this resultant IB and IA, which gives the IC. IA and IB, which gives the IC. So this is the resultant current between the IB and IA. So here VAB and IA phase angle is 36 degrees 52 minutes, and VAB and IB phase angle is 53 degrees 8 minutes. This is the phasor diagram. This is the phasor diagram of this circuit, given circuit. Now, so see here, so powers would be calculated. Powers would be calculated by using voltage conjugates. Powers should be calculated by using voltage conjugates. Here, power whole circuit is P is equal to V into IC. So V is here. See, V how much? V is V is 250 angle of 53 degrees 8 minutes, and I is 25. I means IC is 25 angle of 0 degrees. That is equal to 6250 angle of 53 degrees 8 minutes. Here, so two powers are in there. The power whole circuit is power for whole circuit. That means here two powers are there. So we have to determine that. How can we determine? So here 6250 angle of 53 degrees 8 minutes minus J sin 53 degrees 8 minutes. So here 3750 minus J 5000 minus J 5000. Here this 3750 is the active power, that is P, watts. Units are watts. Now this 5000 is reactive power. This 5000 is reactive power. Here, so minus is denoted. Why here minus is denoted? Here the voltage conjugates, power would be calculated by using voltage conjugates. That means minus, you substitute here minus, here substitute minus. Now in series circuit, that means branch C, the power is, in branch C the power is PC is equal to, so voltage into current. Voltage is how much and current is how much? Here voltage, that means VC. So how much VC voltage? 206 angle of 76 degrees, and current is how much? 25 angle of 0 degrees. Here by voltage conjugate method, so voltage is 206 angle of minus 76 degrees into 25 angle of 0 degrees. So here this is the 5150 angle of cos 76 degrees minus j 76 degrees, that is equal 1250 minus j 5000, that means 5000. Here in the series, in branch C, the power, active power is 1250 watts, and reactive power is 5000 watts. So in branch A is, so voltage into current, that means here voltage is, what is the voltage? VAB is 100 angle of 0 degrees, 100 angle of 0 degrees, and current is 20 angle of minus 36 degrees 52 minutes. Here, so current is in branch A is 20 angle of minus 36 degrees 52 minutes. That is equal to 2000 angle of minus 36 degrees 52 minutes. That gives the 1600 minus j 1200. Now here this is the 1600 is the active power and the 1200 is reactive power. 1200 is reactive power. Now in branch B, the power is voltage into current, that is, so voltage is 100 angle of 0 degrees and that is multiplied with the current, that current is 15 angle of 53 degrees 8 minutes, that is equal to 900 plus j 1200, that is equal to total here, that is the total is, so PA and PB and PC, which gives that 3750 minus j 5000 as a, so that is a power of in circuit, it is a power of circuit. So this is the solution for this. This is the solution for this problem. And next one is find the, here 33, find the value of the power developed in each arm of the series parallel circuit shown in figure. Find the value of the power developed in each arm of the series parallel circuit shown figure. See, observe this one. They are asking power developed in each arm. See this circuit. Observe this one, draw this one. Draw this one. Here, note on it. Here the supply voltage is 15, not 15, 50. 50 angle of 0 degrees volts. The current is I and AB branch resistance is 10 ohms and BC branches, in branch 1 the reactance is minus J20. In branch 2 the impedance is 5 plus J12. In branch 1 the current is I1. In branch 2 current is I2. So what they are asking, find the value of the power developed in each arm of the series parallel circuit. So solution is, in order to find the circuit current, we must first find the equivalent impedance of the whole circuit. Equivalent impedance of the whole circuit. Here, see, observe this one. here in BC branch impedances, that means these two, branch 1 and branch 2 are parallel. This parallel is resultant is in series with this AB branch. So now ZAB so not ZAB, the write in the different way. Why they written ZAB? The notation are giving on wrong way. So here ZBC, they have to write ZBC. ZBC 5 plus J12, this 5 plus J12 and minus J20 are in parallel. 5 plus J12 and minus J20 are in parallel. So now ZBC, write the notation here ZBC, that is 5 plus J12 angle of not angle, 5 plus J12 parallel with minus J20, that is equal 5 plus J12 into minus J20 divided by 5 plus J12 minus J20, that is equal to 13 angle of 67.4 degrees into 20 angle of minus 90 degrees. So minus J means minus 90 degrees divided by 9.43 angle of minus 58 degrees. 58 degrees. See here. So from this here, note that not AB here, very important. Not AB here, this is the BC, ZBC, equivalent impedance of, parallel impedance of ZBC. Note down that, very important. AB, that is equal to, here ZBC is equal to 27.57 angle of 35.4 degrees, that is equal to 22.47 plus J 15.97. So polar form value is, so 27.57 angle of 35.4 degrees, that is equal to, rectangular form is 22.47 plus J 15.97. Now ZAC is equal, here see, observe this one, here ZBC is determined. Now go for ZAC. ZAC is nothing but, so ZBC parallel combination, parallel impedance, resultant parallel impedance, and ZAB impedance. These two are added. So now ZAC is equal to ZAB plus ZBC. ZAB is 10 plus J0 plus ZBC is 22.47 plus J 15.97, that is equal to 32.47 plus J 14.97, that is equal to 36.2 angle of 26.2 degrees. So here ZAC is equal to, resultant is, in rectangular form the value is 32.47 plus J 14.97. In polar form, that is 36.2 angle of 26.2 degrees. Now the current is I is equal to V by Z. Z is the resultant impedance, total impedance, that is ZAC, and the voltage is applied voltage, that is 50 angle of 0 degrees. 50 angle of 0 degrees. Now here I is equal to V by Z. V is 50 angle of 0 degrees divided by Z is 36.2 angle of 26.2, that is equal to 1.38 angle of minus 26.2 degrees amps. So here the current is 1.38 angle of minus 26.2 degrees. That is the amps for current in in equivalent circuit of series parallel. So now or source current. Now so here the power developed in 10 ohm resistor, that is equal, what is the formula for power developed in the circuit, or power absorbed. Power developed means here power absorbed or power taken by the circuit. So see here, not here only they are asking power developed in 10 ohm resistor. Here they given only 10 ohm resistor. What is the formula? In general we can write power is equal to VI cos pi in AC circuit. Here also we can write here the power developed in 10 ohm resistor, that is equal to I square into R. Here I magnitude is 1.38 square into 10, which gives the 19 watts power developed in 10 ohms resistance. So now potential difference. Now potential difference across 10 ohms resistance is, so what is the voltage across the 10 ohms is, that is equal to I into R. What is I here? 1.38 angle of 26 minus 26. Here 26 means here minus 26.2 degrees, that into 10, which gives the 13.8 angle of minus 26.2 degrees. That is equal, so it is in rectangular now, 12.38 minus j 6.1. Now the voltage across the BC is supply voltage minus drop across 10 ohms resistance, which gives the voltage of BC branch. So here the supply voltage is 50 plus J0 and the drop across the 10 ohms resistance is minus of 12.38 minus J 6.1. So which gives the 37.62 plus J 6.1. This is in rectangular. We'll go for the polar, which gives the value is 38.1 angle of 9.21 degrees. So here from that case in I2 in branch 2 current is, so VBC, that means branch VBC, the branch BC voltage divided by the impedance is Z2, that is equal to 38.1 angle of 9.21 divided by 13 angle of 67.4 degrees, that is equal to 2.93 angle of minus 58.2 degrees. So here, so the voltage drop across 10 ohms is 13 point angle of minus 26.2 degrees, and the voltage across BC is 38.1 angle of 9.1 degrees, and the current in branch 2 is 2.93 angle of minus 58.2 degrees. So now power developed in branch 2. So here branch 2 current is I2 and the resistance is 5. So power is I2 square into R2. Power formula is I2 square into R2, that is equal to 2.93 whole square into 5, that gives the 43 watts. It gives the 43 watts. And here no power is developed in the capacitor branch because it has no resistance. In the circuit here in branch 1, why we are not finding the power of branch 1? So in capacitor the power is the active power is not developed or not drawing or note taking. So only reactor power will be developed in the capacitor. So there is no resistance in branch 1. So we could not find out the branch 1 power. So this is the in branch 1 cases the power. So now here we are finding the only in AB branch power and in BC, that is in branch 2 power. So these two powers are we are determined. So this is the class. This is the class is over. So now go for next class.